The molar mass is the mass of 1 mole of a pure substance. Now, if we are discussing the mass of 1 mole of an element on the periodic table, that's very easy to find. Go ahead and take out your periodic tables. Okay? What is the mass of 1 mole of oxygen? 15.9994 grams, correct? Straight from the periodic table. What is the mass, okay? What is the mass of 1 mole of hydrogen? 1.00795 on the bigger one. What's it on the little one? Is it 794? 79, so it doesn't carry it out as far. All right? Now, let's look, okay? Let's look at argon, because we dealt with argon, didn't we? We said that the example we just did for argon was 40.0 grams. What's your periodic table say argon is? Mine says 39.948 grams. So it's very easy to find the molar mass of an element. Now, let's carry that a little bit farther. And as I said on the video, that's the beauty of this right here. You might as well take out your ion sheets too, because if you're like me, I don't have permanganate memorized. So I'm going to have to find out what permanganate is. But in order to do the molar mass, I have to correctly write the formula. That is why, ladies and gentlemen, that I harped to you. If we cannot name, if we don't know our nomenclature, we are going to have problems. If you find yourself in that area, we need to get nomenclature figured out. Period. No ifs, ands, or buts about it. Now, I look at potassium. I know potassium is a K1 plus. I don't have permanganate memorized, but I look here and I see that permanganate is MnO4 minus, correct? So if I'm going to write potassium permanganate, it's going to be KMnO4. Would we all agree on that? Excellent. Now, I need to find the molar mass of potassium permanganate, and it's nice and easy. I'm going to show you how I do these problems. Okay? I break down every one individually and say, okay, I have K, I have Mn, and I have O. I know that potassium, I have 1 potassium. Each potassium will give me 39.0983. So my total mass from potassium is 39.0983 grams. I have 1 manganese. Each manganese has 54.9380. 54.9380 is the mass due to the manganese. Oxygen, I have 4 oxygen atoms. Each oxygen is 15.994. Correct? 15.9994. So 15.994 times 4 gives me 63.9976. So what I'm going to do is I'm going to now take those three values, 39.0983 plus 54.9380 plus 63.9976, and I'm going to come up with 158.0339 grams. Would we agree on my math? I didn't plug a number in the calculator wrong. Did somebody else get that value? All right. So, what does this tell me? That is the molar mass. Okay? And Mason, we said the molar mass was what? The mass of 1 mole of a pure substance. So, 1 mole of KMNO4 is equal to 158.0339 grams. Are we okay with that? What would happen if I would put K2MnO4? If I would have wrote the wrong formula for that, how would it have affected my molar mass? Fletcher? The mass of potassium would have doubled, so I would have had 39.0983 grams too much, correct? So is it important to be able to write formulas for names? They aren't, this isn't going away, I can assure you. I can assure you that that's not going away. Here's example number 2. Example number 2. Go ahead and write the formula for example number 2. Diphosphorus pentoxide. When I do so, I have P2O5, diphosphorus pentoxide. So I'm going to go through and find my molar mass. Once again, I break it down. I have P's and I have O's. I have 2 P's. Each P is 30.9738. So my total mass due to the phosphorus is going to be 61.9476. Oxygen, I have 5 of those. Each one is 15.9994. So I take the 15.9994, multiply that by 5. It gives me 79.997. When I do my math to total those, I come up with 141.9446 grams. Can I get somebody to agree with that number? All right, it is confirmed. So is this molar mass stuff tough? What do you think the most common error with the molar mass is? What? Wrong formulas because we can't name stuff correctly yet. So, molar mass is just reading numbers off of the periodic table. Okay? Reading numbers. Let me see what my next example is, see if I want to, why I put that one on there. Okay, I put that one on there because this is a polyatomic. Go ahead and name this one. I'll give you a second to name it, then we'll write it down. All right, ammonium. Ammonium is NH4, 1 plus. Sulfide is F2 minus. So my proper way to write ammonium sulfide is NH4 parentheses 2S. Once again, as I'm going through, I have nitrogen, I have hydrogen, I have sulfur, all contributing to my molar mass here. So, nitrogen contributes 2 atoms at 14.0067. So 14.0067 times 2 is going to give me 28.0134. My next one is hydrogen. Okay, hydrogen. I look up at hydrogen. I have 4 parentheses 2, so how many total hydrogen? 8 total hydrogen. Each hydrogen is 1.00795 on my table. So 1.00795 times 8 is going to give me 8.0636. My sulfur, I have 1 sulfur. Each sulfur is 32.066. So that's going to give me 32.066. When I do my math, I come up with 68.143 grams. Can we agree on that? No? What did I do wrong? Just numbers on different numbers on different tables? Who used the big periodic table? Did you get my number? All right. So it's going to vary depending on your periodic table, whether you use the bigger one or the smaller one. You use the smaller one, give me a value. What'd you have? 68.1416. Okay. So it's pretty close. Like I said, most of the time when I'm dealing with these and I'm going with them, I take it 2 places past the decimal. Okay? WebAssign, what I think you'll see, has a range that gives you the correct answer. Okay, just so you hit into the range. Now, we're going to get a bell coming up here, but I want you to work this one. We will work this one after the break. So write this down, work it, then I'll work it. We'll check our answers, and we've got a couple more examples to do, then I'm going to turn you loose on it. All right, let's roll here with nickel 3 bicarbonate. Once again, I know my nickel is a 3 plus. Bicarbonate is a 1 plus. So when I write nickel bicarbonate. I have Ni, and my bicarbonate, which is also hydrogen carbonate, is going to be HCO3, and I'm going to need 3 of them, correct? I'm going to need 3 of them, right? So, once again, individually, I have nickel, I have hydrogen, I have carbon, I have oxygen. So I got a bunch of them here. I got 4 of them here to work with. So, nickel, I only have 1 nickel. Each nickel is going to give me 58.6934. So that's going to be 58.6934. Hydrogen, I look at my hydrogen, I have 1, 3, I have 3 total hydrogen. 1.00795, and that's where we could vary a little bit different based on our table. So my mass due to the hydrogen is 3.02385. Carbon is 1 times 3, 3 carbons. Each carbon is 12.0108. And I believe the little table is going to be a little different. Is it 12.011 on the little table? So I'm going to get 36.0324. And finally, oxygen 3 and 3 is 9. So 15.9994 times 9 of them will give me 143.9946. As I do my math to add them together, I come up with 241.74425 grams. A big table people agree with that? Okay. Now, the only thing, I have one more. We're not going to do it. Okay, but I'll show you what the last one is. I'll show you what the last one is. I'm not going to work it, but don't forget that you also need acid rules. Okay, can you name this acid right? Because if you cannot, even if you forget one of the H's, is it going to throw off your mass? Absolutely. Absolutely. Okay.